to discuss dilution. So what is dilution? Probably the dilution is something you already know from the everyday life. For example, when you go to the restaurant and you find out that your wine is too much watery, likely you will think that the waiter had some water in the wine just to save some money. That's annoying, I know. But if you know chemistry, you can go there one day, analyze the wine and say, you know, you made a dilution here. You are highly dishonest. Learn how to do this calculation. It can be helpful. So in chemistry there are two ways of make dilution. First way, you have a container with your solution. So let's say we have sodium hydroxide solution, which let's say has M1 concentration. You will add more water in this container. What will happen? The volume will change. In particular, the volume will increase. But as you can see, the number of NH plus and OH minus particles are the same. So the mole of the solute is the same as it was before. So if you consider the definition of molarity, for example, if now the volume is increased, you will easily understand that the molarity of this new solution is decreased. This is the concept of dilution. The new concentration will be lower. So since the mole are constant, we have this general equation you can use for calculation, which is C1 times V1 equals C2 times V2, where C1 and V1 are the concentration and the volume at the initial state, and C2 and V2 are the concentration and volume at the final state. So with this equation you can easily rearrange that and calculate the new concentration, C2. The second way to make dilution in chemistry is the most used one. In this case you will have already one prepared concentration. Let's go on with the sodium hydroxide. You will take a defined amount of this solution with graduated pipette. You transfer this amount, this known amount, in the second volumetric flask, and then you will add more solvent. What is happening? Again, you start for a more concentrated solution and you will end up with a more diluted solution. But what is going on? You cannot say that the mole of sodium hydroxide of these two flasks are the same. In this case, it's not true. But what is true? So let's see what is going on. Once you're taking this solution with a pipette, the concentration of the solution inside the pipette is the same of the initial solution. What is changed is the number of particles inside. So what is changed is the mole. Because we have been taking only a small amount of these particles and also solvents. But the mole that I put in this second flask, they are the same if compared with the mole inside the pipette. As you can see now, in this second flask we have less Na plus and OH minus particles. And as you can see, these particles are more far away from each other because they are separated by the solvent, which is now in bigger amount. So what is the equation we can use in this second case in order to calculate the concentration of our second flask? Well, it's simple. The equation is the same. So C1 times V1 equals C2 times V2. However, V1 is not the volume of our first solution, but is the volume we have taken inside the pipette. So be careful only to this. So you can call it in a different way, probably, to not get confused. You can call it as volume of taken amount, for example. So BT. So as I have said, the second way of preparing dilution is the most used one. Why? Well, it's simple, because sometimes you have to buy already prepared solution. For example, you buy nitric acid. Nitric acid you will buy at defined concentration. So when you have to prepare your sample for doing reaction or whatever, probably you won't need the same concentration, but you will need less. So it's not a good habit to just dilute all of your batch of nitric acid. It's not convenient. You can do that if you are rich, but usually it's not done. So it's more convenient to take a calculated amount and make the dilution as we have seen. What is also highly common in chemistry is to do serial dilution. So what is serial dilution? It's starting from one concentration, make the dilution as we have seen in the second method, and then going on, use the second flask, make again another dilution, and so on. Why this is done? This is done because you sometimes need very low concentrated solution. For example, 10 to minus 5 molar concentration. This is very low concentration, or 10 to minus 6. And you need it because you have to do some analysis with this sample. So you use serial dilution because this very low concentration cannot be prepared by weighing your sample. You cannot use this scale because the amount to weigh will be too low. So you use this method of serial dilution to do that. It's annoying, but it's working. So with that having been said, we can go to the second part of this video, in which I will show you some problems which can help you with your calculations. So let's go to see our first problem about dilution. As usual, we will write the data. So we have this time 55% of NH03 solution. Okay, solution. The density of this solution, so the density of solution 55% is 1.39 gram over milliliter. We need to prepare a new solution. This new solution will have the total volume of 0.600 liters. So it's total volume. Total volume new solution, okay? So we'll remember. Then the density of this new solution will be 2.5 molarity. So this is again new solution. So the question is, what is the volume of the more concentrated solution? So the solution at 65% of nitric acid we need to take away. To take away from this solution in order to use this volume to build the new solution here. First of all, let's remind what is percentage by mass, and let's remind what is molarity. As usual, we will write the definition. Percentage by mass is the mass of solute divided by mass of solution times 100. Molarity is mole of solute divided by the volume of solution in liters. This is mole, so it's mole. Okay, we have our definition. Now I will do a small drawing of our situation. So our situation is that we have this more concentrated solution, which is 65% by mass of nitric acid. And we need to prepare a new solution, which is more diluted, and its concentration is expressed in molarity. The total volume of the final solution should be 0.6 liter. So we need to take some amount of liquid from here to put this amount of liquid here, and then to add water in order to have dilution. Okay, so let's repeat slightly better what we have to do. We have to take a precise amount of volume from this solution that we will now calculate, and we will do this through a graduated pipette that you will have in the lab with the bulb here to take the liquid. So you take the liquid through this, and then you will put the liquid here, the exact amount of volume, which is the answer to our question, and the rest will be only to add water. After you did that, you will add water, and you will add water till to reach the mark on this volumetric flask, which is volumetric flask with total volume of 0.6 liter. Of course, you have to find a volumetric flask with this total volume, okay? So now, how we can do? We need only to know how much we have to take with this pipette. So the question is, what is this amount? Each time you have to do problems about dilution, you need to watch to the target solution first, because the target solution will tell you actually how much you need to take from here. So now the question is, how many moles I need to take from this solution? You need to know the amount of solute you need to take here to have the target solution. Now the amount of solute, we can calculate it in this case using moles, because we have molarity here like concentration. So the mole of HNO3, so the mole of solute, will be molarity of my solution, which is 2.5 times the volume, and the volume is the total volume, of course, 0.6. The answer to this is 1.5 mole. So now we know how much solute we have to take to find here, okay, to find here. Since this concentration is expressed in percentage by mass, we cannot use directly mole to know the amount I can find here, okay? So we have to translate this information with the information we have here. So simply we will convert this into the mass of solute. So the mass of solute is of HNO3 is simply the mole of solute times the molar mass of nitric acid that you can find on the internet or you can calculate. So it's 63.0 gram over mole. So the mass of nitric acid we need to take is 94.5 grams. Actually, there is another problem. When I take something from here, I cannot take only the solute, but I will take solute plus solvent. I will take the solution, okay? So we know that I need to take from here 94.5 gram of nitric acid, but I cannot take only nitric acid because there will be water. So I need to know the mass of solution which is containing 94.5 grams of nitric acid. And I can do this easily using this equation. Okay, so we have 65%. Let's use the definition. And then we have the mass of solute we need to take is 94.5 grams divided by mass of solution times 100. This entails that the mass of solution equals to 94.5 grams divided by 65 times 100. So the mass of solution is 145.4 grams. Okay, so now we know that 94.5 grams of nitric acid are contained in 145.4 grams of this solution. So is this, let's say, part of the solution. We know the mass of the solution. But we do not have a scale, okay, to take this amount. So in the lab we will take a graduated pipette, so I need to know the volume. Now the volume is easy to calculate just using the concept of density. The density, of course, of this solution. So density is the mass of solution in this case divided by volume of solution. Of course, is the solution which is 55% by mass. So this entails that the volume of my solution that I need to take, so the answer to my problem, is the mass of solution, so 145.4 divided by density of the solution, which is 1.39 gram over milliliter. So the answer is 104.6 milliliter. So in the end, you need to take 104.6 milliliter from this solution, the more concentrated one. You will take it with, thanks to this pipette, you will put this amount here, and then you will have the rest of water. So the rest will be less than 500 milliliter, okay? In order to reach the total volume of 0.6. So when you are doing problem that are dealing with dilution, you need to think first of all about your target solution. Your target solution will give you the information about the mass of solute or the mole of solute you have to take from the more concentrated solution. But you have also to remind you that you will never take only the solute, but you will take the solute plus the solvent. So you have to ask yourself, what is the amount of solution that contains the amount of solute I need in order to build this new solution, okay? And now let's move on to the second one. Let's see our second problem. We have a solution which is 0.20 molar solution of HCl. 350 milliliter of this solution have been taken. So let's say have been taken away, okay? So I've been taken away from this solution to build a new solution with a final volume of 1.4 liter. So this is the volume of the new solution. Let's call it V2. So the question is, what is the molarity of the new solution, M2, okay? As usual, let's write the definition of molarity, which is the mole of solute divided by the volume of solution. So this is our definition. Now let's draw something to understand what we have in this problem. So we have this more concentrated solution of chlorhydric acid, okay, in water, which is 0.20 molar. And we have built, starting from this solution, a new solution which is more diluted. And this solution has a final volume of 1.4 liter. Okay, this is the final volume. Volume 2. We have made this solution starting from this by taking a small amount of volume from this, and this small amount is 350 milliliter. And then we have put this into this, okay? And then you add water in order to reach the total volume of 1.4. Of course, water is the solvent. So we want to know the molarity of this new solution. So the molarity of our M2 solution will be given by N2 divided by V2. So we know V2 because V2 is 1.4 liter, is this final volume, but we need to know N2. If I know N2, I know the answer to my problem. N2 is the amount of solute that I have here, but this amount is the same amount that I have been taking by this volume here. Okay, it's like this part. This part has the same amount of mole. So N2 is this we have taken here, which is the same I have here. Okay, so it's mole we have taken from the more concentrated solution. Another thing we have to consider is that when you are taking a volume from a more concentrated solution, this volume will have the same concentration of the starting solution. So we know that this amount we have taken has the same concentration for the taken volume, okay? Since also this amount has the same mole we have here, this means that it's easy to calculate this mole, because this mole will be given by M1, so the molarity of the more concentrated solution. Okay, this is M1, this is M2. And N2 is here, okay? Divided by the volume we have taken. Let's call VT. VT is this volume here, VT, okay? The volume we have taken. And I put here N2 because the amount we have here is the same of mole we have here. So we have also N2. This means that N2 equals M1 times VT. So N2 is 0.20 molarity times 0.350 liters. We have to use liters, okay, not milliliters. So N2 is 0.07 mole. We can put this mole here and we have the answer to our problem, because M2 will be given by 0.07 divided by 1.4 liter, and so the answer is 0.05 mole over liter. So the new molarity is this one, 0.05 mole over liter. So this is the answer to our second problem. So please be careful when you're doing this problem with dilution.